So in this we will see class 11th physics chapter thermal properties of matter, and in the
we will see what is heat and what is temperature. So heat is basically a form of energy which produces a sensation of warmth in our body. Its SI unit is joule and it is represented by capital Q, and its formula is Q is equals to mc delta T. And what is temperature? Temperature is the degree of hotness of a body. It also tells us the flow of heat, in which direction it is flowing. It is measured with the help of a thermometer. Next topic, we will see different scales of measuring temperature. First is Celsius scale. It is a scale of measuring temperature in which from ice point to boiling point of water there are 100 divisions. And second one is Fahrenheit scale. It's also a scale of measuring temperature in which from ice point to boiling point of water there are 180 divisions, that is from 32 degree Fahrenheit to 212 degree Fahrenheit. And you should also know the relation between degree Celsius and Fahrenheit, that is C is equals to 5 by 9 into F minus 32. Next topic is thermal expansion. It is the property of matter by virtue of which a body changes its shape, area or volume etc. when its temperature is changed. So there are three types of expansions, thermal expansions. First one is linear expansion, second areal expansion, and third volumetric or superficial expansion. Linear expansion is the lengthwise expansion of a body due to change in temperature. Its formula is L dash equals to L into 1 plus alpha delta T, where alpha is the coefficient of linear expansion. In delta L depends on temperature and original length. Second one is areal or superficial expansion. It is the area-wise expansion of a body due to change in temperature. Its formula is A dash is equals to A into 1 plus beta delta T, where beta is the coefficient of areal expansion. A dash is the change in area after heating, and delta T is the change in temperature, and A is the original temperature. Third one is volumetric or cubical expansion. It is the volume-wise expansion of a body due to change in temperature, and its formula is V dash is equals to V into 1 plus gamma delta T, where gamma is the coefficient of volumetric expansion. Our next topic is specific heat capacity. It is the amount of heat required to raise the temperature of 1 kg of substance by unit degree. Its formula is C equals to Q by M delta T, and its SI unit is joule per kg per Kelvin. And here you should also note that the specific heat capacity of water is 4184 joule per kg per Kelvin. Hence the coolants have very high specific capacity like water. Land breeze and sea breeze occurs due to high heat capacity of water. Next topic is molar specific heat capacity. So it is the amount of heat required to raise the temperature of 1 mole of a gas by unit degree. It is denoted by capital C, and its formula is C equals to Q by mu delta T, where C is the molar specific heat capacity, Q is heat energy, mu is number of moles, and delta T is change in temperature. And molar specific heat capacity is further divided into two categories. First is molar specific heat capacity at constant pressure, and second molar specific heat capacity at constant volume. So first we will see at constant pressure. It is the amount of heat required to raise the temperature of 1 mole of a gas by unit degree, keeping the pressure of the gas constant. And in constant volume, it is the amount of heat required to raise the temperature of 1 mole of a gas by unit degree at constant volume. Here molar specific heat capacity at constant pressure, also we can say Cp, is greater than Cv, that is molar specific heat capacity at constant volume. Next topic is latent heat. It is the amount of heat required to change the state of matter from one state to another. And like molar specific heat, it is also divided into two categories. First one is latent heat of fusion. It is the amount of heat required to convert the solid state of a substance into liquid state. Here Q is directly proportional to M and it is denoted by LF, that is LF is equals to Q by M and its SI unit is joule per kg. Second one is latent heat of vaporization. It is the amount of heat required to convert the liquid state of a substance into gaseous or vapor state. Here also Q is directly proportional to M and latent heat of vaporization is denoted by LV and its SI unit is also joule per kg. Our next topic is anomalous expansion of water, or we can say abnormal behavior of water. We know that when we change the temperature of water, like when we decrease the temperature of water, the volume of water also decreases, and as density is inversely proportional to volume, therefore the density of water starts increasing. But this change takes place only till 4 degrees Celsius, that is the density of water is maximum at 4 degrees Celsius. Below 4 degrees Celsius, water shows an anomalous behavior or abnormal behavior, that is, the volume of water start increasing instead of decreasing, and hence its density also decrease. Next topic is regulation. It is a phenomena of ice melting under pressure and refreezing when the pressure is reduced. You can also see in the given diagram. And there is one more important diagram, that is change of state among solid, liquid and gas. You can see the given diagram on the screen. Next topic is transfer of heat energy. The process of transferring heat energy is known as transfer of heat. For example, if we transfer heat energy from sun to earth, it is an example of transfer of heat. And now we will see what are the modes of transfer of heat. So there are basically two modes of transfer of heat. First one is conduction. It is a process of transfer of heat in solids during which no actual movement of particles takes place, but heat is exchanged from one place to another. Second one is thermal resistant. Thermal resistance is the obstruction occurred to the flow of heat by the solids from one place to another. Next topic is thermal conductivity. It is the property of material due to which it allows heat to pass through it, and factors on which heat depends are area, change in temperature and time. And its formula is Q equals to minus K AT delta theta upon delta X, where K is the coefficient of thermal conductivity and theta by X is the temperature gradient. Next topic is convection. So convection is a process of transfer of heat used in fluids. In this process, the particles actually move from one place to another. Some examples of convection are land breeze and sea breeze, trade winds and monsoons. Next topic is radiation. Radiation is the process of transfer of heat energy from one place to another without the interference of any intervening medium. It is considered as the best method of transfer of heat energy because in this process no heat energy is wasted or lost. For example, sunlight travels a long distance from sun to earth without any involvement of any medium. Our next topic is Newton's law of cooling. This law states that the rate of loss of heat is directly proportional to the temperature difference between the body and the surrounding. And we can say minus dq by dt is inversely proportional to theta minus theta dash, where theta is the temperature of body and theta dash is the temperature of the surrounding. And in the end, we will finish this chapter by discussing two small laws which are also very important. First is Wien's displacement law. According to this law, the wavelength of heat radiation is inversely proportional to its Kelvin temperature, that is, lambda is inversely proportional to 1 by T, and we can say lambda is equals to B by T, where B is the Wien's constant and its value is 2.89 into 10 to the power minus 3. Next law is Stephen's-Boltzmann law. According to this law, the amount of heat radiation emitted is directly proportional to the fourth power of its Kelvin temperature. That is, E is inversely proportional to T to the power 4, and E is equals to sigma T to the power 4, where sigma is the Stephen's constant and its value is 5.67 into 10 to the power minus 8. And in the end, we will see black body radiation. So first of all, we will see what is black body. An idealized, opaque and non-reflective body is called a black body. It absorbs all the electromagnetic radiations when incident on any body. And next we will see what is electromagnetic radiation. So it is a thermal electromagnetic radiation within or surrounding a body in thermodynamic equilibrium with its environment, emitted by a black body.